Alright, so I just want to cover box fill a little bit more. I'll probably try and do another one of these examples and post that as well. So anyway, this one comes right out of your homework, but I want to review a couple things. So this is the table that's right in your EWR book. It tells you how much volume to account, or how many volume allowances to account for any given object that might be in a box. So we'll come back and reference this later. We also have this table from your book. It's actually NEC table 314.16b, which tells us how many cubic inches to allow for any given conductor. And again, we'll come back to that here too. So our question here tells us we got a bunch of stuff in this box here basically, and ultimately they want to know what's the minimum volume size of a box that I may use to contain all these items. So a couple things worth noting here. Let's take a look. It's a 3-gang masonry box. They tell us we're going to have no ground wires pulled in here. That's uncommon, but really what they're saying is don't count any grounds. We don't have them. So it's kind of a little loophole they're throwing you there. Also, the box is going to contain 3 4-way switches, 12 travelers, or just a fancy way of talking about a current carrying conductor, and 2 other circuit conductors. So probably neutrals, but again, they're current carrying conductors. So at this point, and again, they tell us we're using number 12 wire as well. So at this point, let's go back and see what should we count in this box. And as I go down the list, do we have internal cable clamps? No. A single volume for each. Support fittings? We don't have any support fittings. Do we have devices? Yes, we absolutely do. So we'll have to account for them. And they tell us we're going to count a double volume of the largest conductor in the box. Alright. So moving down, we have add a single volume for equipment grounding conductors. We said we don't have those. Isolated grounds we don't have. For conductors less than 12 inches that are just looped in the box, they don't count anyway. Or we don't have them, I'm sorry. So then conductors 12 inch or longer that are looped, we got a double volume. For conductors that originate outside the box, we're going to add a single volume for each conductor. And that's exactly what we have here. Conductors that started somewhere else ended up in our box. So we're going to have to count this. Okay, and the rest, we don't really have those either. So at this point we come back to our sort of word problem. Let's first count our 3-way switches. So remember, we count a double volume based on the largest conductor. All we have is number 12 here, but we're going to sort of start our tally here at this point. So we have 3 switches that are double volume. So we're going to go 1, 2, that's one switch, 3, 4, that's the second, 5, 6. There's your 3 switches. So what else do we count here? 12 travelers or current carrying conductors. We're just going to take them at face value, 1 apiece. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And lastly, we have to pick up the 2 other conductors. Again, just face value, single volume. So 1, 2. Okay, and of course we can tally that up. We have 20 volume allowances, right? And since they're all number 12, there's no need to split those up. But let's jump over and check how are we going to size that. What amount of space do we need for number 12? So to do that, we're going to go back to our table 314.16b. We can see if we're using number 12s, we should include 2.25 cubic inches in our calculation. So again, we have our 20 that we counted times 2.25 cubic inches for number 12. That of course comes up to 45 cubic inches. Okay, so everything in that box, we're going to need at least 45 cubic inches. So if we go back, all they want to know, what box must have a minimum volume of how many cubic inches? Of course, what we just calculated here of 45 cubic inches.